we're going to talk about this time division of a line segment. This is a generalization of midpoint of a line segment. When you say division of a line segment, it is a point dividing a line segment into a number of parts, no? Or in a given ratio. Okay, guys? So that's what we mean by point of division. Points of division can be internal, can be external. So if I have, let's say, a line segment given by this, and it is divided in between, let's say, into two parts. So this is the first part, and this is the second part. Okay, guys? So they are not equal generally, but can be equal if this point is at the middle. So if this is the point of division P, and this is my first point, and this is my second point, we call P internal point of division. But if you have a case like this, let's say I have a segment, and this segment is extended, let's say, 2 times its original length. It is extended up to this. Okay, guys? Yan. Reaching this point. So if this is my P1, and this is my P2, this is my point of division, which is outside P1 and P2. We call P here this time external point of division. Or you can call that point of extension. Clear, children?
Yes.
Point of extension. So mathematically, we can talk of point of extension, which we are going to consider also as a point of division. But that is, again, external point of division. And then the normal one, inside, which is internal point of division. Clear? So let's say I have this line segment drawn in the Cartesian plane. Then we have this case. The formula that we are going to have works on both cases, no? Whether it is an internal point of division or external point of division. You do not have to worry. If this is our y sub 2, this is y sub 1, this is x sub 1, and this is x sub 2. And let's say my point of division is somewhere here. So let me call it P, and this is P2, and this is P1. Coordinates of P, X, Y, no? So meaning, this is X, and this is Y. Okay? So we have the following point of division formula. If P whose coordinates x and y is a point of division, meaning it's either what? Internal or external. Okay? Of the line segment connecting P sub 1 whose coordinates x sub 1, y sub 1, and P sub 2 whose coordinates x sub 2, y sub 2. And if P is located so that K is equal to P sub 1 to P taken directed over P sub 1 to P sub 2 taken also as directed, then the coordinates of the point of division are given by the following formulas. X sub x is equal to x sub 1 plus k times x sub 2 minus x sub 1. Y is equal to y sub 1 plus k times y sub 2 minus y sub 1. Okay, guys? So let us have the following examples. Number 1. Find the point of trisection of the line segment joining P1 coordinates for -3 and P2 coordinates 1, 2. Nearer P sub 2. Okay? I want to find the point of trisection of the line segment P1, P2 that is near P2. Okay, guys? Nearer. Because there are two, I think, there are 2 points of division. Nearer P sub 2. So let us illustrate arbitrarily. So meaning I'm not going to draw the actual figure, no? So we have a line segment, and this line segment is to be divided into how many equal parts? 3, no? 1, 2, and then 3. 1, 2, 3. So this is P sub 2, P sub 1. I want the point of division that is nearer P2. There are 2 points of division. This P and another one. But I want nearer P sub 2. So this is the one that I am looking for. Am I clear, guys? Let the coordinates be X and Y. Okay? So how to find this P of X sub XY? Okay? So to get this P, we are going to consider each part 1 unit. So let's say this is 1 unit. You can assign any length. No? So the convenient one is 1. 1. You can have 1/2 each. You can have 3 each part. You can have square root of 8. Whatever you want. Whatever is convenient. Okay, guys? So if each is 1 part, so what is the directed distance from P1 to P2, no? From P1 to P2, 3. So we'll able to form the K, no? By the way, we're looking for the point of division P, coordinates XY. Again, what is our K? First point going to the point of division over first point going to second point. First point going to P, 2 units. First point going to second point, 3 units. Am I correct, guys? First point to point of division, 2 units considered. P1 to P2, 3 units. So the ratio is 2/3. So that is our K. To solve for X, we have X sub 1 plus K times X sub 2 minus X sub 1. But what is our X sub 1? 4, no? X sub 2, 1. So we have 4 plus 2/3 times 1 minus 4. Am I correct, guys? So simplifying, we have positive 2. Am I right, guys? So that's the value of X. What about the value of Y? Y sub 1 plus K times Y sub 2 minus Y sub 1. But what is my Y sub 1? Negative 3. Plus 2/3. Then Y sub 2 is 2, no? Minus negative 3. Okay, guys? So simplifying, we have negative 3 times 3, that is negative 9 plus 2 times 5, that is 10, no? All over 3. Am I right, children? And that is 1/3. Therefore, our point of division nearer P sub 2 is given by 2, whose coordinates 2, 1/3. Get it, guys? Okay? Let us have the second problem. A line segment from the point A, coordinates 4, negative 1, to B, coordinates negative 3, negative 5, is extended to a point C. whose coordinates x and y four-thirds of its original length. Find the point C. Okay, guys? So again, let's illustrate this arbitrarily. So consider this line segment. I'm going to extend this. How long, guys?
4/3.
4/3. Okay? So meaning, I'm going to divide this into 3. 1, 2, 3. And the extension, how many of these parts? How many is the extension? 4/3. So we have one of this, one total of this, plus a part. Am I correct, guys? Am I right?
Yes, sir.
Guys. So 1, 1, 2, 3, 4. 4/3. Okay? Am I correct with my extension? Guys? Pag 3/3, it's the whole thing. It's just double the length, no? But 4/3 meaning one whole plus one part. Okay, guys? So if I'm going to consider this as one unit, another one, how many units are these? 4 units. Am I correct, guys?
Yes, sir.
If this is considered arbitrarily 3 units, so we have here how many units? 4. Okay, children? So 1 unit is 1 part. So we call this first point. That is our A. Our B is our second point. And this is the point of extension. So we have to form what? K first, no? So we want our C. So how to form K, guys? K is equal to first point to the dividing point. Our dividing point is C. Over first point to the second point. Our second point is B. So what is AC? A going to C. How many units considered, guys?
7.
7. Over AB, 3, no? So the ratio K is 7/3. Solving for X, we have, let's solve X here. X sub A plus K, X sub B minus X sub A. What is our X sub A? 4. K, 7/3. What about X sub B? Negative 3, no? Then minus 4. So getting 3 times 4 is 12. Then minus 7 times 7 is 49, no? So all over 3. Am I right, guys? Guys, am I correct?
Yes, sir.
What's the value? Could you please help me compute the value?
Negative 37/3.
So negative 37/3. What about the y? So that is y sub A plus K, y sub B minus y sub A. So getting y sub A is, what is y sub A? Negative 1 plus 7/3 times -5 minus -1. So that is equal to -1 minus 7 divided by 3 times 4. What's the value, guys?
Sir, -31/3.
-31/3. So finally, what is our point C? -37/3, -31/3. Get it, guys? So this is our answer. Okay? Okay now, guys? What about number 3? A line segment connecting P coordinates -5, 2 and Q connect coordinates -3, -5 is divided into 5 equal parts. Find the point of division nearer Q. So let us arbitrarily draw the segment. I'm going to divide this into how many equal parts, guys? 5, no? 1, 2, 3, 4, 5. So how many points of division do we have, guys? Guys, how many points of division?
4, sir.
4. Which is the one nearer Q? So we have, there are 5 points of division, no? So let's say R1, R2, R3, R4. Which one are we looking for? R1, R2, R3, or R4?
R4.
Take note, it is nearer, not the nearest. Okay, so it means what? R3. Am I right, guys? Guys,
Yes, sir.
Opo.
if nearest, R sub 4. Nearer, Q. Next nearer, R sub 2. Farthest, R sub 1. Okay, guys? So, we're looking for R sub 3, no? Let's call R sub 3 XY. Okay, guys? So, let's determine K first. To get K, we have first point to the dividing point. So that is P to R sub 4. That is P to R sub 3, no? All over P to Q. Okay? So, what is P going to R sub 3? 1 unit, another 1 unit, another 1 unit. So how long considered? Guys. 4, right? Or 3 only? 3, no? Over 1, 2, 3, 4, 5. Over 5. Am I correct, children?
Yes, sir.
What is my x? That is x ni what? X sub 3. So let's call it x sub 1 plus k x sub 2. I mean, x sub 1 ni p, no? So x sub p, let me check it again. X is equal to x sub p plus k x sub q minus x sub p. Okay? Let's substitute. What is x sub p? Guys?
-5, sir.
Negative 5 plus 3 over 5. X sub q is negative 3 minus negative 5. Yan. So, what's the value? Negative 5 plus 3 divided by 5 times 2, no? So that is negative 19 over 5. What about the y? That is y sub p plus k times y sub q minus y sub p. Getting 2 plus 3 over 5 times negative 5 minus 2. So simplifying, we have 2 plus 3 divided by 5 times negative 7. So that is negative 11 over 5. Okay, children? So therefore, our R sub 3 coordinates negative 19 over 5, negative 11 over 5. Any question with this, guys? So let's now move to another concept in analytic geometry. Sometimes we find necessary to determine the direction of any line relative to the coordinate axis. No? This leads to the concept of inclination and slope. So if you want to give direction to a line, so we are going to make use of the concept of slope or the concept of inclination. Either of the two, no? So let's start with angle of inclination. Any idea of what angle of inclination is? Guys, what is an angle of inclination? Guys. Guys, what is the angle of inclination of a line? Guys. Guys. It is the smallest counterclockwise angle. You had this in trigonometry, right? Counterclockwise. That the line makes with the positive direction of the x-axis. Okay? So, special case, which is not covered in the definition. If a line is horizontal, the angle of inclination is 0 degree or 0 radian. Okay, children? So if theta denotes the angle of inclination, then we have theta is between 0 degree and 180 degrees, including 0, because we have a special case for our horizontal line. Or in radian measure, from 0 to less than 180 degrees, meaning from 0 to pi, no? Pi is 180 degrees. So this is in radian measure, in degree measure. Is that clear, children? So to illustrate, we have the following possibilities, no? So possible for the line to have what? Positive, acute angle as the angle of inclination. So from positive direction of the x-axis going to the line, let's call it theta. Or you can have it obtuse angle if your line is in this way, no? In this position. So the arrow is pointing to the line. So this is our angle. It is also possible that our line is what? Vertical. If the line is vertical, then our angle is what? Angle of inclination is, guys, 90 degrees, na? Okay? Let's say we have a vertical line. So the angle of inclination, 90 degrees. Is that clear, guys? And then for the last one, of course, if horizontal, the angle of inclination is 0, not 180 degrees. We will be considering the 0. Okay, guys? Any question with this, children? Guys?
None, sir.
Okay. Another term related to angle of inclination, giving direction to the line also, we have slope of a line. So when you say slope of a line, it is the measure of its steepness. In Filipino, katarikan. Mathematically, the ratio of what? The ratio of its rise to the run. Okay? Some authors use the term gradient for the slope of a line. So instead of slope is used, no? The term gradient is used instead of slope. Okay, guys? Any question, guys? So, to illustrate, if I have this line, let's take 2 points on this line. So I can start measuring from this point going upward direction. So we call this rise, no? Rise. And then run, going to this point. So this is rise, and this is my run. So if slope is represented, for instance, by M, then we have what? M is equal to rise, in this case, positive, over run. Also, in this illustration, positive, no? Yan, okay? Now, in the second one, let's say, possible also that my line is positioned in this manner. Okay? Taking again 2 points. So I can consider this as my run. No, sorry. I can consider as my rise, and this is my run. But this time, my rise is negative. My run is still positive. So slope here is rise, considered negative because going down. Overrun, considered positive because going to the right. So the slope here is negative. While in the first one, the slope is what? Positive. Okay? So the slope is positive if the line rises up to the right, and it is negative if it is rising up to the left. Okay? Guys, if you have a negative rise, that is actually called fall. We mean fall. Okay, guys? How are the angle of inclination related to slope mathematically? So, if I have this line segment or line in general, so we have to consider 2 points. Let's say any 2 points will do. No? The angle of inclination of this line is theta. If I draw line parallel to the x-axis from this point P1 and from point P2 parallel to the y-axis, we draw line, we form a right triangle here. Okay? So this is my y1, y sub 2, then x sub 1, x sub 2. We say that this is y sub 2 minus y sub 1. This is x sub 2 minus x sub 1. This is also theta, no? Because this line is parallel here. So, and the line will act what? As a transversal axis to these parallel lines. So their corresponding angles are what? Equal. Get it, guys? So from your trigonometry, guys, inclination of line or angle of inclination is given by what? Or slope is given by, in terms of angle of inclination, guys? Or anyone? Slope is equal to the tangent of what? This is theta, no? Tangent of theta. Rise over run, that is slope. Equivalently, in terms of coordinates, that is y sub 2, definition of tangent, opposite, over, adjacent. Am I right, guys? Guys? Guys, still alive?
Yes po.
So here, we do not want, of course, theta to be what? Not 90 degrees. Otherwise, undefined. While here, we do not want x sub 1 to be equal to x sub 2. Okay, guys? Now, if you're going to solve theta here, we have m is equal to what, guys? Tangent theta, no? Solving for theta, we have what, children? Theta is equal to arctangent of, what notation are you using? Arctangent or with a superscript -1? Guys. But don't forget to add 180 degrees times K. Where K here is either 0 if M is greater than 0. And it is 1 if M is negative. Okay? Get it, children? Any question with that? If M is greater than 0, it means theta is what? Is acute. If M is less than 0, it means theta is obtuse. What about relationships of slopes of parallel and perpendicular lines? Two non-vertical lines have the same slope. Take note, non-vertical lines, because for vertical lines, the slopes are not defined. Okay, guys? Have the same slope. So, if I'm going to consider these lines, line 1, line 2, let's have parallel to that line. So this is line 2. Their corresponding angles of inclination, so we have the following. Theta sub 1 here. This is theta sub 2. So we say that their angles are equal, no? The x-axis here acts as the transversal axis, intersecting or cutting the parallel lines. Corresponding angles are equal. If we take the tangent of each side, we have tangent of theta sub 1 equals tangent of theta sub 2. But we define tangent of the angle of inclination as a slope. So m sub 1 is equal to m sub 2. Get it, children? So this is how their slopes are related. Okay, guys? What about if lines are perpendicular? If two lines are perpendicular, like in this case, let's call this line 2 and my line 1. is the pink one. Oh, let's have them meeting perpendicularly here. No? Perpendicular here. So meaning this is 90 degrees. 90 degrees. Okay? This angle. This is theta sub 2, the angle of inclination of the yellow, while the angle of inclination of this pink, theta sub 1. If we call this L sub 1. So how are their angles related? These angles of inclination. Theta sub 1, that is exterior angle of this triangle, is equal to the sum of the two remote angles. That is 90 degrees plus theta sub 2. If we take the tangent of each side, we get this. No? Tangent of theta sub 1 equals tangent of 90 degrees plus theta sub 2. But from your trigonometry, I think you're not yet in there, no? The identity for this is negative cotangent of theta sub 2. But cotangent theta sub 2 is 1 over tangent theta sub 2. Then negative here, that is tangent theta sub 1. But how do we define tangent of the angle of inclination? Slope. Therefore, we say that m sub 1 is equal to negative 1 over m sub 2. Get it, guys? So this is how the slopes of perpendicular lines are related to each other. So their slopes are negative reciprocals of what, guys? The slopes of two slant lines are what? Are negative reciprocals of each other. Any question here, guys? Children? Guys? No question? Okay.
No, sir.
Yes. Any question, guys? No more? Okay. You do not have to worry. This will be posted and also the link will be shared to you. Equivalently, the product of their slopes negative 1. So or M1 times M2 is equal to negative 1. Okay? What about the angle between two lines? If two lines intersect, there are angles formed between them. Okay, guys? Like for instance, if I have these two intersecting lines, let's call this my line 1 and this one my line 2. And let's say this is the angle formed between them. Let me consider this angle measured in counterclockwise from line 1 to line 2. If beta is an angle measured in counterclockwise direction, from line 1 to line L2, with respective slopes M1 and M2, then we say that the tangent of this angle between them but measured from line 1 to line 2 is equal to M sub 2 minus M sub 1 all over 1 plus M sub 2 M sub 1. Take note that beta is generated from line 1 to line 2. So this formula works in that way. If I'm going to solve this for beta, we get what, guys? Beta is equal to arc tangent of M sub 2 minus M sub 1 all over 1 plus M sub 2 M sub 1. Okay? But don't forget to add 180 degrees times K, because possible that the value inside of the arc tangent is positive, possible to be negative. If positive, no problem. We take K equals 0. But if this is negative, since you want your beta to be counterclockwise, so we have to add 180 so that it will be in the second quadrant, meaning between 90 degrees and 180 degrees. Get it, guys? So we're here. K is equal to 0 if what? If tangent beta is positive, and it is 1 if tangent beta is negative. Get it, guys? So meaning beta is what here? Acute. Positive, huh? And here beta is obtuse. Okay, children? Any question with this formula, guys? Let's have specific examples, no? For the concepts that we discussed. Number 1, find the slope and angle of inclination of the line passing through P1 for negative 5 and P sub 2 negative 2 negative 3. Let's have this. 4 negative 5 negative 2 3 negative 3. Am I correct? Let's illustrate. Although you can solve that without the illustration, just to show why the values are like are like what we are going to have. No? So let's see. Just to check. For negative 5, one, two, three, 4, 5, 5, 2, and then 1, 2, 3, 4. But since y-axis negative along the negative, so this is negative 2, this is negative 4. Then negative 1 here, negative 2, negative 3. Okay? So for negative 5, where is that? For negative 5, I think I need one more scale. Negative 5 here. Am I right, guys? For negative 5. Negative 3, negative 2. Am I right, children?
Yes, sir.
Yeah. Then we connect, no? Oops. Then just extend. So this is our line. Okay, it will intersect the x-axis. So just make a line parallel to the x-axis, and this is the angle of inclination. Okay, guys? Because I don't have any more space so that I can intersect the x-axis and draw the direction. So we can have just this way. And what do you expect for the slope, guys? What do you expect for the slope? This is supposed to be the slope. Rise, then run, no? Our run in this case is negative. This is negative, this is positive. Okay, guys? Guys? Mali ba ako? Parang negative 2, negative 3. Let's just change the given so that I'm not going to change the negative 3. Let me just change this because I have already plotted and it's easier to change the given. Negative 3, negative 2. Okay now, guys? Okay. So negative 3, negative 2. And then, so this is our point B, no? What is our point A? This, no? Am I right? At P1, P2. P1. And then this is P2. Okay? And here. And here. So we're looking for, what are we looking for? Slope and theta, right? So to solve for slope, we have using coordinates, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Oh, what is y sub 2? Guys?
-2, sir.
Negative 3. Negative 2. Negative 2. Then, y sub 1. Negative 5.
Yes, sir.
All over x sub 2. Negative 3. X sub 1. 4. Right? So, am I right, guys? So, what is m? Children?
Yes, sir. -3/7.
Negative 3/7. So this is our slope. So expected to be negative, no? Because the line is rising up to the left. What about theta? Theta is equal to what? Arctangent of 100, slope, arctangent of m plus what? 180 degrees times k. We're going to take our k as what? 1, no? Because our slope is negative. So we have arctangent of negative 3/7. But we have to add what, guys? 180 degrees times 1, or simply 180 degrees. Your choices for this additional term, either 0 or 180. What is that, guys? What's the angle now? So what is theta, children? Guys, anyone? Would you please give me the value? In your trigonometry, you had your trigonometry, right? Approximately in 2 decimal places, degrees, nearest 2 decimal places. Arctangent of negative 3 divided by 7, then plus 180 degrees. Is it 156, guys?
Sir, 156.80 po.
80 degrees. Okay. Thank you. That's it. Okay. Next, number 2. Find the value of y if the slope of the line passing through A coordinates for negative y, for y, and B negative 5, 7 is negative 5. Okay? So it's all right not to draw the actual figure. So let us just have an arbitrary illustration. Let's say this is my line having a slope negative 5. And this contains 2 points, A and B, no? Let's say this is my A, this is my B. Okay, guys? So we're looking for the value of y, satisfying the given condition. So it is said that the slope of the line segment AB is supposed to be equal to what? Negative 5, no? Okay? We're looking for the value of y, which is one of the coordinates of A. But what is the slope AB, considering the given points? That is 7 minus y all over negative 5 minus 4. And that is equal to negative 5. Okay, guys? So we have negative, negative, that is positive, no? Positive 45 is equal to what, guys? 7 minus y. Am I right?
Yes, sir.
What is my y? Negative
Negative
30. 30 what?
negative 38.
38. So that's the value of y. Okay? So that the condition is satisfied. Any question? Okay, number 3. The line passing through point A, coordinates 5, negative 3, and B, coordinates x1, is parallel to the line joining what? Joining or to the line through C, coordinates 9/2, 0, and negative 3, 5. Determine the value of x. Okay? So given, let's draw just what you call this, an arbitrary illustration. So there are 2 lines. Let's just have 2 lines. Although not drawn to scale, especially regarding the slope, because we haven't solved the slope yet, whether negative or positive, no? But what we know, they are parallel. The first line contains 2 points A and B. The second line contains what? C and D, no? Okay? We're looking for the value of x satisfying the given condition. First, let's solve for the slope of line AB. What is the slope of line AB, guys? 1 minus negative 3 all over x minus 5. This is supposed to be equal to the slope of the line passing through CD, no? And what's the slope of CD? 5 minus 0 over all over negative 3 minus 9/2. Okay? So the left side is 4 over x minus 5. The right side, we multiply by 2, both the numerator and denominator, to simplify this complex. So giving 10 over, this is negative 6 minus 9. So simplifying further, we have 4 over x minus 5, the right side, negative 2 over 3. Am I correct, guys? Guys?
Yes, sir.
Yes, sir.
So we have 12 is equal to what? Guys? Negative 2x plus 10, right? So what is 2x? Negative 2. Or what is x?
Negative.
Negative 1, no? Okay, that's it. So this is the value of x that we're looking for. Okay? Any question with that, children? No question? Okay, so we have number 4. Show that determine if the line determine if the given points, what are these points? 1, -1, 4, 1, and 10, 5, are collinear. What do we mean by collinear, guys?
Points of the same line, sir.
Points lying on the same line, no? Points that are contained on the same line. How will you know that the points are contained on the same line? Guys, so to analyze it, so first let's draw, no? Then 5. Yeah. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 5. This is 3. Then we have -1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 11 here, 4 here, 5, 6, 7 here. So let's plot the points. So 1, -1. So along here. 4, 1. So somewhere here. 10, 5. 10, 5. Am I right, guys? Somewhere here.
Yes, sir.
So let's try to connect them. And let's see if this will really be contained on the same line. How will you know that they are really on the same line? Guys, what's happening? Oh, there's a problem. Wait a minute. I do not know what's going on. I will say first. I do not know. I'm not writing, but it happened like that. I don't know. Let me check. So let's continue. Let's plot the points. 1, -1. 4, 1, 2, 3, 4. Let me label first. It's hard to count. This is 5. This is 11, no? And this is 2, 3. Okay. -2 somewhere here. 4, 1, no? Okay. 4, 1 here. And then somewhere here, 10, -5. Am I right? Somewhere here.
Yes, sir.
Oh. This is just an approximate. So I'm going to pass a line. Let's see if this will really be on a straight line. Those points. Oh, what are we going to do to determine or to show that this is really on a straight line? I mean, the points are really on the straight line, guys. This is my point A, no? My point B, and this is my point C. Oh, what are we going to verify, guys? Guys.
Sir, the slope of
Verify what? Slope of what? Verify that the slope from A going to B is the same with what? Slope from B going to C. Am I correct? Because in a straight line, the slope must be constant. Anywhere you go, from one point to another point, then another point to another point, you must have the same rise over run. Is that clear, children? If this is not true, the points are not lying on the straight line, meaning not collinear. Get it, guys? Children, what is the slope of AB? AB. 1 minus -1, 4 minus 1. 1 minus -1 all over 4 minus 1. What is this slope, guys?
2/3,
2
sir.
over 3. What about the slope from B going to C? Let's see. 5 minus 1 all over 10 minus 4. 5 minus 1 all over 10 minus 4. Am I correct? That is 4 over 6. What is 4 over 6?
2/3.
2/3. Are they equal? Yes. No. Therefore, guaranteed that the given points are what? Are collinear. So meaning, the given points lie on a straight line. Okay, children? Any question with that? Guys? What number are we now? 4, 5. Number 5. Find the interior angles of a triangle at A and C, given that the vertices are A 4, 1, B -4, 9, and C 5, 6. Okay, so let's illustrate the problem. We have y-axis, x-axis here. Okay, guys? -1, -2, -3, -4, -5, -2 here. 1, 2, 3, 4, 5, 6, 7. This is 7, 3, -1, 1, 2, 3, 4, 5, 6, 7, 8. One more. I missed one unit. So 9 here. So this is 2. This is 4. This is 6. This is 8. Okay, guys? So let's plot the points. -4, 9. -4, 9. Oh, no. No, no, no. I'll move this one. -4, -9. Oh, is that right, guys? Guys, am I correct?
Yes, sir.
Then we have 4, 1. What about point B? No, point A. 4, 1. 4, 1 here. Around here. Then 5, 6. 5, 6. Yeah. Okay, children, let's connect to form a beautiful triangle. Yeah. It's hard to hit this point. Okay. We are looking for what angles? Angles at what? At A and B. At A, where is A? Here? 4, 1, A. Where is my B? It's almost time. B here. Where is my C? Here? Guys?
Yes, sir.
So we are looking for what? Angle at A and C. Beta 1, counterclockwise. So from here, going here. Be sure your arrow is correct, because your slope will depend on where the arrow is pointing and where the tail is pointing. Counterclockwise, so some going here. Okay, guys? So that is how to form angle between two lines. From line 1 to line 2. So depending on where the arrow is pointing, where the tail is pointing. Where the tail is pointing, your slope 1. The arrow is pointing, your slope 2. So we're looking at angles B1 and beta 1 and beta 2. Get it, guys? So we need the slope ng AC, no? What is the slope ng AC, guys? AC. 6 minus 1. All over 5 minus 4. So that is 5, no? What about slope ng AB, guys? AB. 9 minus 1 all over -4 minus 4. Am I right, guys?
Yes, sir.
Is it -1?
Opo, sir.
What about slope ng BC? Guys, 6 minus 9 all over 5 minus negative 4. Okay, is it negative
1/3, sir.
3 over 9 and that is negative 1/3? Get it, guys? So how to form formula for tangent of beta 1? So slope where the arrow is pointing, m ng BC, m of AB minus m of where the tail is pointing, AC. Get it, guys? How is the quotient being formed? All over 1 plus MAB, MAC. Okay, children? Guys, let's get this. Put it here. Let's finish this one only. So getting what? What is M of AB? Negative 1. M of AC? Positive 5. Am I right, guys? All over 1 plus negative 1 times 5. Okay? What is this, guys? Negative 6 over negative 4, which is equal to what? 3 over 2. And that is positive. It means we are going to take our K what? 0. So what is our beta 1? Guys, arctangent of simply 3 over 2. No more 180. Is that clear, children? What's the value? Arctan of 3 divided by 2.
56.31.
56. So beta 1 is approximately 56.31 degrees. Let's form formula for the next one. What about tangent beta 2? What's the formula? Slope where the arrow is pointing, m of AC, minus where the tail is pointing, m of BC, all over 1 plus MAC, MBC. Okay? Let's get this. So that's it. So that's how you form a formula. Okay, children? So we have, let's rewrite tangent beta 2 is equal to m of AC minus m of BC all over 1 plus m of AC, m of BC. All you have to do is to substitute values. Okay. What is m of AC, guys? Positive 5, right? M of BC, negative 1/3. Am I correct, guys? All over 1 plus 5 times negative 1/3. So times 3 over 3 to get rid of the denominators in each part of the fraction. 15 plus 1 all over 3 minus 5. Am I correct, guys?
Yes, sir.
Is it negative 8? Therefore, what is our K? 1. So what is beta sub 2? Arc tangent of negative 8 plus what? 180 degrees times 1. Okay? What is the value, guys?
97.12, sir. 0.13.
97.12 degrees. Let me check. Arctan negative 8 plus 180 degrees. 97.13, no?
0.13, sir.
13 degrees. Any question with this, guys? So look at how the formula is being formed. You don't really memorize the way it is exactly, no? But how to form the formula for the angle between lines. Okay? You have to consider where the point is, where the arrow is pointing and the tail is pointing. Any question before I leave, guys?